In this video, influence lines for trusses will be discussed. Trusses are often used as primary load-carrying elements for bridges. Hence, for design, it is important to be able to construct the influence line for each of its members. As shown in the figure below, the loading on the bridge deck is transmitted to stringers by the stringers, which in turn transmit the loading to floor beams, this one, and then to the joints along the bottom chord of the truss. Uh, so, let us solve a simple problem. Draw the influence line for the force in member BC of the wiring truss. Indicate numerical values for the peaks, and all members have the same length. So, sa truss, mas dali lang ni siya, mas dali lang mag-draw ani kay ang position nimo limited raman. You'll only be considering the joints, no. Dili pa rin sa beam nga pwede ka mag-interval. So medyo daghan to siya. There is a joints lang. So in this case, kaupat ra, no. Like when the unit load is at A, what's the force on member BC? When the unit load is at B, what's the force on member BC? And also when the unit load at C and D. Okay. So uh to plot influence lines for member BC, we need to find first or draw first the influence line for the reaction at the left support. So, why left support? Because in solving for BC, we are going to use method of sections. Either direta mag-cut or dire for as long as na ang member BC. And when we use method of section, and then if you analyze the left side, we need the value of RA. So, therefore, mo na ito unahon ng kuha. So, for RA, anita na. So, first, when the unit load is at A, what would be the value of RA? So, you can use statics. Like summation of moment sa D, makuha ni mong RA. And that will be equal to 1. And then move when the unit load is at B, what's the value of RA? Statics again. The answer is 2/3. And then for C, summation of moment sa D again. You can solve for RA. The answer is 1/3. And then last, when the unit load is at D, RA is 0. So that's the influence line for RA. So next is mag-cut ka og section. Okay. Method adjunct is not advised kay doge man to. So direct solution is using method of section. So either dili ka mag-cut or they are same ang resulta. Okay, so this one, muna siya ang left part sa truss and muna itong unknown, BC. Force and member BC. And we all know sa method of section na if you want to solve for one member, you have to sum up moment sa intersection sa other two members. So kining daw ka members diri mo F, G, and BF ipa-intersect na nimo, they will intersect at joint F. Diri ka mag-moment para ang moment ng duha ka force ay 0. So kana ano, so RA and then you have unit load. Okay. Let's generalize X na lang. Although we all know nga ang unit load or ang load will only act at the joint, di ba? Bali, X will only be equal to 20, 40, and 60. Pero for demonstration purposes, inahan nilang generalize sa to X. Sige. Sa map moment at F, the moment arm of FBC is 17.32 kay 60 ni 60, 60, 60. Equilateral, so 20 ni and 20 sine of 60. This one is 17.32. Okay siya? And then the moment arm of 1 is 30 minus x. Kaya 30 ni siya. Kana, 30 man na. Yeah, minus x. So, this is the expression of FBC. Okay. Now, same sa beams na kung magkuha ka og equation for shear and moment or the influence line, bali, you have one equation when the unit load is before the cutting section and another equation after the cutting section. Same also sa truss. O, bali, ang unit load will be considered only kung ang unit load naa sa joints A and B. Uh, when it reaches joint C, wala na unit load makita diri sa left side. So kung magsama pag moment sa F, you will only be considering F, B, C, and RA. Therefore, kini na term, mawala na siya when X is greater than 20 or specifically when X is equal to 40 and 60. So balik kini siya, tama na ni siya sa X equal to 20. Joint B bali. So ano na to ni? This expression is valid for X equal to 0 to 20 or 0 and 20. And then remove this term for X equal to 40 and 60 or X greater than 20. Tingnan. So we're now ready to plot values. So first, when the unit load is at A, your RA is equal to 1 and our X is equal to 0. Ba? Okay, so ato ni substitute dire kini sa may blue na kan. Kaya ang X niya 0 man, dire pa man na siya. Substitute 1 and then 0. The answer would be or is equal to 0. And then the unit load at B. So kung naasa B, ang RA na to is equal to 2/3. Diba? Pero ang X na to is equal to 20. Kini na, tama naman sa 20 ni. And 2/3 tapos 20, the answer is 0.577. And then unit load at C, RA is 1/3. And then ang X na to na kay 40 naman. So kini na atong gamit kay lapas naman. More than 20 naman. So there na ta. RA 1/3 na FBC 0.577. And then last at D, RA is 0. Tapos ang X na to 60 man. So dili na ni siya. Dili na. Bali mo lang itong pattern, no? Mo na itong pattern, no? Para mga systematic imong solution na nakay-guide ba. Lahat na to, 0, 0.577, 0.577, and then 0. And then you connect, and then, so this is the influence lines for member BC. Okay. Another one. For the truss shown, construct the influence lines for the bar for each of the lettered bars. So I will be showing the solution, the influence lines for members B and C only. So it's up to you to solve for A and B. Okay, so same procedure. First, you draw the influence lines for the reaction at the left support para guide nimo in solving for the members of the forces. So first, place the unit load sa left support and then compute for R using statics. Sum up moments sa right support and 1, and then move the unit load to the next joint sa bottom chord, and then use statics again. The RA is equal to 5 over 6, and then move RA is 4 over 6 or 2 thirds, and then at the center by symmetry, ang reaction sa duha ka supports are equal. That's 1 half or 3 over 6, and then move it's 2 over 6 or 1 third, and then move 1 over 6, and then last is 0. So money influence line na to. Okay, so after this, cut tayo nga. And since member C itong paon, dito tayo mag-cut. Naman. Okay, C. And again, to solve for C, sum up ka og moment sa intersection sa duha ka members. Okay. Let's denote it as joint one. Label it joint. Reaction and the unit load. Arbitrary lang yung position, location, and distance of x. And then, conditions of equilibrium. Sum up ka moment sa 1. You have this. FC times 25 plus 1 times, this is 75, di ba? Taman sa joint 1. 75 minus x, then minus r times 75. So, analyze again. Kaya na expression for FC, valid lang ni siya. Tama dire. When the unit load is at this joint, or simply when x is equal to 50. There tama. Beyond that, sa next joint, wala na kayo unit load makita. Yeah? So, tama na sa 50. More than 50 or 75, 100, 125, and 150, mawala na nga term. Ani, mawala na. So, ang billion, 75R over 25 na or simply 3R. O mo siya. So, kini expression when x is greater than 50. Specifically dire, 75, 100, 125, 150. Uh, After this, plot na yun. Assume ka. Oh. At x equal to 0, bali na unit load diha. Ang R ni mo is 1. Ang butang ni mo na 1, 0. The answer is 0. And then sunod, when x equals 25, 25 na andere, ang R ni mo is 5 over 6. Substitute na 5 over 6, 25. Ana, 0.5. And then x equal to 50. Dire, 50. Ang reaction is 2 thirds. And substitute 2 thirds, 50. Money FC. Sa mid-span at 75, lapas na, nandun yung unit load. So, wala na appeal, kinara. The reaction at mid-span is 1 half. So, 1 half times 3, that's 1.5. And then, pag 100, kini, 1 third. 1 third times 3, that's 1. And then for 125, the reaction is 1 over 6. Substitute 1 over 6 times 3, that's 1 half. And then last, when x equals 150, r is 0, let's see, is equal to 0. And then plot na yun. So 0, 0.5, 1, 1.5, and then 1, and then zero point 0.5, and then 0. Connect na yun. Connect, yeah. And the last. So this is the influence lines for member C. Eh? Okay, you do the same for member B. Pero sa member B, dili ka mag-cut. For RA, okay, this is the influence lines for RA. Ah. Okay, that's it. A cut and not a B. So for B, uh, since the other two members are parallel, we cannot use summation of moment. Instead, we will use summation of force along vertical. So RA and then 1 x, although x is not part of the equation, but x will be our guide kung unsa ang expression na atong gamiton. So, summation force sa y, ana, so, any expression is valid only when the unit load is up to this point. No? Ang unit load na ana dire, dili na siya. Kaya dili lang siya makita. Bali, from the cutting section and then analyze the left side, wala na unit load makita nimo. Kaya naa naman siya dire na join. So therefore, kini expression is valid only or applicable only for x equal to 0 and 25. Or 0 up to 25. 0 and 25. Sa 50, wala na. No? Wala na unit load, then if b is equal to r lang. Okay. Yan na na. And then substitute. When x equals 0, r equals 1, just refer to the influence line for r. So 1, 1 minus 1, 0. At 25, dire 5 over 6. So valid pa man yun. Tama sa 25 man. So 5 over 6 minus 1, it's negative 1 over 6. And then sa 50, kini na ka. Kaya x is greater than 25. So 2/3 50 and equal na sila. Kung saan reaction, makakuha na ang force of B. 75, 1 half, so 1 half, plus 100, 1/3, so 1/3 jud, 1 over 6, 1 over 6, and then sa last point, RA or the reaction at the left support is 0, therefore FB is also equal to 0. And then you plot 0, negative, and then mo shift sa positive 2/3, and then 1 half. Same na lang yan. 1 over 1/3, 1 over 6, and then 0. And then connect na yan. 1, 2, 3, 4, 5, and 6. So, maura ni siya ang kung saan pag-plot sa bar force sa truss. Baga na siya procedure ba? You start with the influence line for the left support and then cut kag section passing through the member nga i-consider nimo, and then yung statics depende lang unsa na kondisyon imong magamit, either sa machine moment, sa machine force, and then know the restriction of your expression, ang limit sa value sa x, and then plot dynamo, place the load at different locations, and then solve for the bar force of the force of the member. Okay, that's it. So next to discuss applications sa influence lines, like uh, how to determine the value of functions given ang mga loads. Now, let us first go back sa condition. Uh, for loadings, once the influence line for a function, either reaction shear moment, has been constructed, it will then be possible to position the live loads on the beam, which will produce the maximum value of the function. Two types of loadings will now be considered. For concentrated force, inganani. For any concentrated force F acting on the beam at any position x, the value of the function can be found by multiplying the ordinate of the influence line at the position x by the magnitude of F. Eh, inganana. Oh, and for uniform load, in general, the value of a function caused by a uniform distributed load is simply the area under the influence line for the function multiplied by the intensity of the uniform load. Yan, ana. So muna itong gamiton karon kung mag-solve na ta og problem kay. Sige, let's go back. Uh, Given the simple beam, 24 feet long, construct the influence lines for the shear and bending moment at a section 8 feet from the left end, and obtain the maximum shear and maximum bending moment for the section resulting from a moving uniform load of 3 kips per foot and a movable concentrated load of 50 kips. Okay. Solution. We have this beam 24 feet long, and then kuhaon na to ang influence line for the shear and bending moment at a section 8 feet from the left end. So first, shear sa 8 feet from the left end. Dire, no? 8 feet. And using Miller-Bruce law principle or any other technique, money influence lines sa shear at 8. Negative 1/3 and 2/3. So, kung yun sa pagkuha ng 2/3, my technique is this one, no? 16 divided by 24, mo na 2/3. While this one, it's 8 divided by 24, that's 1/3. Okay. Now, since gusto ka og maximum value, like considering the uniform load, ang pagkuha sa value sa function kung uniform load is to multiply the intensity of the load by the area under the influence line. Ato pa, since moving load siya, live load, pwede mo putlon. Dili siya necessary nga ibutang nimo tanan sa whole length. Kaya kung ibutang nimo tanan ang load sa whole length, ang imong net area magamay kay maapil man yung negative So plus minus magamay sa. So therefore, dili rin mo ibutang load sa positive nga area lang kay pwede mo putlon. So ina niya. Oh. Dili lang mo ibutang uniform load positive area lang. Actually, it's depende kung ano sa'y bigger. But since mas dako ang positive area over the negative area, so direta. Kay kung may diri maximum shear regardless of sign man eh. Either positive or negative, whichever is bigger. But in this case, mas dako man na positive, so dito is positive. Ana. And in the case of the concentrated load, ang value sa function kung concentrated load product man sa magnitude og ordinate. So therefore, dito siya nimo ibutang sa pinakadako og ordinate para maximum value mo makuha. And in this case, mo ni ang maximum ordinate 2/3. So therefore, dili ko nimo siya ibutang. I-place kay movable man siya. Sa nasa nimo pwede ibutang. So dito na to. 50, no? Compute na dayon. Oh. Concentrated load magnitude times ordinate plus intensity sa uniform load times area sa influence line. So 1/2 16 times 2/3. Pana lang. Okay. 49.333. Okay. Sa moment, okay, 8 feet. Kabalo naman using Wheeler-Bruce law. Rotate na counterclockwise and clockwise. Mo ni ang resulta. And ang value niya is EB over L. Bali A siya, and then B, tayo, kanala yun, L. So that would be 8 times 16 divided by 24. 16 over 3. So, for the loads, whole length man sabi, positive area, same man. So, i-maximize ni mo. Tibuok length ni mo ibutang ang load. Oh. Kaya, dako mo yung area sa influence na. And for the concentrated load, of course, dili mo ibutang. Kaya na dili ang highest na ordinate 16 over 3. Ibutang mo ulit. And then compute. Moment at 8, magnitude sa concentrated force, and then ordinate intensity sa uniform load area. 1/2 of base 24 times altitude 16 over 3. Money ang answer. Another is series of concentrated loads. How do you analyze or how do you determine the maximum function for a series of concentrated loads? So that is a simple beam 45 feet long carries moving loads of 10 kips, 10 kips, and 5 kips spaced 5 feet apart. Calculate the maximum left reaction and the maximum shear and bending moment at a section 15 feet from the left end. So, dito mag-start sa letter A. Maximum left reaction. So, mo nitong beam, draw tag influence line sa left reaction. Simple na, no? Miller-Bruce law, push ni mo upward by 1 unit, mo ni ang influence line. So, ang idea sa series of concentrated loads is you place the first load over the highest ordinate. Dere. Ingana na. First load, butang mo diha. And then the distance between loads kay 5 feet man. So, pagkuha sa value sa function, bali RA is to multiply the magnitude of the force times the ordinate. So ang kulang na lang ang ordinate aning 10 o 5. Ano siya? Kuha na to na by ratio and proportion. This is our first position. So kuha mo ni by ratio and proportion. Bale y is to 40 or 1 is to 45. Pwede na. The answer is this one. And then kanina po, y is to 35 equals 1 is to 45. Yan. Or in my case, kung ang ako style is based slope equals rise over run. So, rise or y is to x. So, to solve for y is equal to slope times x or rise is equal to slope times run, di ba? So, paon ako ang slope daan. Kini, known mo siya. Y is to x. So, 1 over 45 mo na akong slope. Ako na siya i-store na siya. Store na ko ng slope. After that, pagkuha na ako sa mga ordinates, ipamultiply na lang ako itong slope sa run. Like this one. Ang run ani kay 35 man. So, katong slope nga nakastore na ko, either sa A, B, or any other key sa calcio. Like sa A ni mo, i-store mo sa A. Ano rin ka? Alpha A or A times 35. Mo yung gawas. A times 40. Mo yung gawas. Mas paspas yan. Yeah. So, once makuha na niyo mo ng ordinate, pwede na rin ka mag-solve. Kana. Magnitude times ordinate, magnitude, ordinate, magnitude, ordinate. Mo yung answer. 22.78. Next ani is kini i-move na nimo the second load i-locate nimo sa or butang nimo sa highest ordinate. That would be your position 2. Like this one. Kana position 2 and paano po yung ordinates. Now, what happens is ang kining una na load 10 nilapas na, so this will not be considered anymore. So, okay na lang. Mm. So, ato na sa slope times run kay same raman sa slope. Or similar raman na no, 8 over 9. So, 8 over 9 siya. And then compute. 14.44. Okay. Mao dahil ni ang kondisyon pag mag-solve ka problem na series of concentrated loads. If ang value sa function continues to increase, mag-continue sa gaog move sa imong mga moving loads. Oh. Like, kung dako pa lang ni siya kasi 22, then what do ka sa position 3? Where ang 5 keeps na load, mo inabot lang diri sa highest ordinate. Kung nag-increase pa lang ha. So, mo na siya ang condition. Pag ang value sa function ga continue og increase, continuous ka og move sa imong loads towards the left. Pero the moment nga mag-decrease stop na ka, and ang maximum value is katong previous na position. So in this case, 22 ang 22.78 ang maximum na left reaction. Yan na. Okay. Same also sa any other function. Basta ka concentrated series of concentrated loads inana. So shear sa left support kana so mao man ni ang influence line sa shear. Negative 1/3 and 2/3. So then ni may patong ang concentrated ang first nga load kay mao man ni pinaka-highest na ordinate. Ana. That will be your position 1. And then next is paano mo ordinates kana Another slope na siya, 2/3 divided by 30. Ano yung slope? Store na po niyo. Store sa A. Ikaw man, ano po? Slope times run. A times 25. Mao ni siya. Next, A times 20. Mao ni siya. Yun na. And then compute. The value of the function is 14.44. It's this magnitude times ordinate. Next, position 2. I-move ni mo ang load. So, ang second load, na dire. Inana siya. Position 2. And then ordinate. Pwede na ka ma-apply ani kay same naman sa slope. On 5 man eh. So, 10 imong run. Di ba? 10. So, A times 10. Ang A man ito imong slope. Di ba? Makuha ni mo. Tapos dire, same run na dire sa babaw. 5/9. Kitag 5 naman na tanan. And then compute. And again, nag-decrease imong value. Therefore, ang maximum is kini. 14.44. And for moment, ano yung influence line, rotate and then rotate, ano isa? AB over L, 15 times 30 divided by 45. Ilan? 30. 10. That's all. 10. And then place the loads. And then position 1. And then ordinate. Another step to pagka. 10/30. Store sa nimo. Balik-balik mo niya. 25/3. 20/3. Tapos mo ni mo moment. Next, position 2. Kana, no? Okay. Kini siya, lahi ni siya slope. Kini sa right is 10/30 man ang slope. This sa left, it's 10/15. So, lahi yung slope na. Mo na yung ordinate, mo sa na yung ordinate. And then, value sa function, 208. Ni gamay na sad from 216 man. Therefore, the maximum is 216.67 hits. Okay, so yung nana lang pag plot sa or pag-determine sa value sa function. Kung combination sa uniform load o concentrated load or series of concentrated loads. So, I hope na nasabtan ninyo ang ako explanation. Thank you.